Astronomy experts have recorded 9 unusual characteristics related to 3I Atlas. But the 10th characteristic stands out above all. It is the one that has caused the most reputable researchers to ponder deeply. Near the Sun's region, the object from outside the system changed its velocity. Not from ordinary gravitational pull, not related to escaping gas, but from a completely different cause. All calculations predict that such action would create massive chaos, a gigantic stream of material, a dust rock cloud taller than the highest mountain peak, billions of tons of particles and vapor hurled into space. Yet observation equipment detects no sign whatsoever. No dust column, no fragments, only silence accompanied by movement. And if from November to December 2025, subsequent measurements still detect no trace of that vanished material mass, then 3I Atlas will achieve what no comet has ever done: adjust its path in space without losing any tangible mass, an invisible thrust, a motion arising from emptiness. Join me in exploring this 10th anomaly to its very end, and surprisingly the anomaly almost no one mentions, because if it can adjust its direction once, what prevents it from doing so again? Perhaps straight toward our planet. If this secret intrigues you, as it has captivated me, don't just observe from afar. Join this tracking journey. Like to show your support and follow to not miss the next updates, because the story is unfolding in real time. Share where you're following from the current time, and your thoughts on this 10th anomaly. And if you want to help this group grow, spread this information on social media platforms, forums, or even in private conversations. You are the motivation for us to continue pursuing topics like this. So thank you for your companionship. Part 1. The reveal. Imagine an object from a distant star system hurtling through our solar neighborhood at a speed that makes an ordinary bullet seem stationary and performing what no comet has ever achieved. You might think this is just another strange cosmic rock, another attention-grabbing headline, but the reality is different. This rock stands out on its own, and the reason it stands out will make you think a lot if you take the time to consider. The object has a name that sounds like a security code string: 3I Atlas. For us, that's 3I Atlases, where the initial letters stand for interstellar, the third confirmed visitor from outside the solar system. Before it were Oumuamua, sparking debate over whether it was a comet, asteroid, or something entirely different. Next was Borisov, behaving like a normal comet and providing reassurance. We once thought the universe was as predicted. Then 3I Atlas appeared and the universe replied not to jump to conclusions. Here is the information to grasp right before diving deeper. This object has 9 confirmed characteristics, 9 distinct ways it breaks the rules, skews probabilities, forcing astronomy experts to re-examine formulas. We will examine them right now, but first you need to pay attention to what has not been widely mentioned. The 10th anomaly, elevating the level of strangeness from high to requiring a complete rethink of knowledge about object motion in space. The 10th anomaly is like that. 3I Atlas appears to have undergone non-gravitational acceleration near perihelion, its closest position to the Sun. In other words, the object changed speed and direction in a way that pure gravity cannot explain. Comets often do this. They heat up, release gas, eject material, receive thrust from escaping ice and dust. That is normal. That is within predictions. Except in this case, if 3I Atlas accelerated as measured, it must have ejected over 5 billion tons of material. 5 billion tons. No mistake. And when a comet ejects 5 billion tons of ice dust rock, you see it clearly. You see the gigantic glowing material cloud. You see the tail stretching across the sky. You see the sudden brightness spike. You see the evidence. And so far we have seen nothing. Not at the required level. That means only one of 2 possibilities is true, and both are hard to accept. Either we missed the material cloud for some reason, making this a strange but still natural comet, or the object accelerated without the expected mass loss. And if the second possibility is true, we face something that violates understanding of momentum and mass, something that changes direction without pushing material backward, something that moves as if with intent. Before assuming I'm exaggerating, let me tell you about the 9 known anomalies. This is not speculation. This is measurement, observation, and peer-reviewed strangeness. First, its orbit. The object entered on a retrograde orbit, meaning opposite to the majority of objects in the solar system. but the path coincidentally aligns unusually with the ecliptic plane. The probability of random occurrence is about 0.2%, not impossible but uncomfortably low. Second, the timing. It passed near Mars, then Venus, then Jupiter, all within a very rare time frame. Some calculations put the coincidence probability below 0.005% if the path were completely random. Again, not impossible, but when low probability events stack up, you start wondering if you're watching a coin or a magic trick. Third, its size and velocity. The object is larger and faster than previous interstellar objects we recorded. Oumuamua was small, tumbling, gone before thorough study. Borisov was mild-behaved, standard. 3I Atlasis, neither small nor well-behaved. It moves with purpose, or at least with momentum, suggesting very long travel. Fourth, its composition. Gas ratios are skewed. Heavily skewed. Nickel to iron ratio. Nickel to cyanide. Numbers that don't match solar system comets. They are extreme. They are exceptions within exceptions. Fifth, water content. Most comets are basically dirty snowballs full of water ice. Comet 3I Atlas has about 4% of its mass is water. 4%. That's not a dirty snowball. That's something entirely different. Something formed under conditions so different it's like from a separate recipe. Sixth, polarization. When light reflects off the object, it scatters in an unseen way. Maximum negative polarization. Minimum around minus 2.7% at a phase angle of 7 degrees. Sounds technical, but it means the surface or surrounding particles reflect light in a way no comet does. It's a polarization fingerprint that doesn't match the database. Seventh, brightness and color. When near the Sun, Comet Atlas brightened faster than any known comet, and not just brighter but greener. Comets usually brighten because dust dominates reflected light. This comet is greener than the Sun. That's counterintuitive. Skewed. Eighth, anti-tail. Comets have tails pointing away from the Sun, pushed by solar wind and radiation. 3I Atlas created a jet stream toward the Sun in anti-tail. Sometimes just geometric illusion tricking the viewing angle, but here observations show it's real. Material pushed toward the Sun, or at least in a direction impossible under normal comet physics. And ninth, origin direction. The object came from the same celestial direction as the 1977 WOW signal within about 9 degrees. The WOW signal was a strong narrowband radio signal detected by SETI, never repeated, never explained, and from a sky point coincidentally where 3I Atlas originated. What is the random coincidence probability? Let's say the universe likes jokes. So those are 9 separate reasons the object shouldn't exist as it does. 9 ways it violates expectations, models sense of normal. And then the 10th reason, acceleration without visible debris. Thrust without exhaust motion change, without reaction mass to explain it. That's the anomaly that ties everything together and makes it concerning. Because this is the worrisome part. If we're wrong about this, if the debris cloud is there but unseen, then 3I Atlas is a humbling lesson. A reminder the universe is stranger than thought, but still follows general rules. But if November and December 2025 observations show no such cloud, then we face a darker possibility. Either physics knowledge is incomplete or something out there knows more. In the coming time, we analyze each part. Look at observations, numbers, blind spots. Discuss what real data says. Implications, consequences if the object behaves as shown. Explore speculations, alternative explanations, possibilities that sound science fiction but grounded in real measurements. And ultimately, you have the information to decide for yourself. Natural strangeness, measurement error, or something entirely different. Upcoming observations hold the key. From November to December 2025, that's the time frame, when 3I Atlas reappears. When it approaches Earth closest on December 19th, global telescopes point at it searching for the debris cloud. If found, mystery solved. If not, mystery greater. So start with the timeline. Discuss how it was detected, what was measured, why the measurements keep the astronomy community awake. Part 2. The latest breakthrough observations. The story began on July 1st, 2025. A telescope in Chile, part of the Earth asteroid impact warning system, caught a faint light streak moving through Aquarius. ATLAS is designed to find near-Earth objects threatening asteroids, but this time different. Hours after the initial observation, experts realized they were looking at something that shouldn't exist. Wrong orbit, wrong speed. The orbital curve showed the object not from the neighborhood. They reran the data, checked for errors, called for confirmation from other telescopes. By the weekend, official results. Hyperbolic orbit of interstellar origin. The third confirmed object after Oumuamua and Borisov. Named 3I Atlas. Initial letters standing for interstellar equivalent to a stamp not from here. But unlike Borisov obeying laws, behaving like a normal comet, 3I Atlas immediately showed strange signs. Retrograde path opposite to the solar system's rotation direction but nearly aligned with the ecliptic plane. This is unusual. Most interstellar objects arrive at random angles because three-dimensional space has no preferred direction. 3I. Atlas hugging the planetary orbital plane suggests extreme luck or something else in the timing too. The object crossed the ecliptic plane 26 days before perihelion. Passed near Mars near Venus. After reaching perihelion closest to the Sun on October 29, 2025, just 8 days after solar conjunction, the object was obscured by the Sun from Earth. The arrangement combined with close passes and obscuration surprised many. Not impossible, but too tight for comfort. Perihelion distance about 0.1 astronomical units. About 15 million kilometers from the Sun. Close enough for surface temperatures to vaporize most materials. Close enough for a comet to erupt in spectacular gas dust. And 3I Atlas showed activity. There was a gas cloud, a faint coma, around the nucleus. Spectroscopy showed carbon dioxide dominating the mix. Fairly common except what happened next. Astrometry from instruments like the Atacama Large Millimeter Submillimeter Array, one of the most precise for positioning, comparing observed position of 3I Atlas near perihelion with predicted position based only on gravity. Gravity from the Sun planet's known factors. And the discrepancy about 4 arcseconds. Sounds small. An arcsecond is 1/3600th of a degree. 4 arcseconds is nearly the width of a hair seen from across a football field. But in astronomy, 4 arcseconds is huge. Like a canyon, the difference between knowing exact position and something pushing it off orbit. When plugging the deviation into dynamical models, finding the force causing it get a heart-stopping number. Non-gravitational acceleration. The object accelerated or changed direction requiring force beyond gravity. The only natural explanation, outgassing. Material pushed out of the comet rocket effect. How comets normally work. Created from ice rock dust frozen for billions of years. Near the Sun, heat vaporizes ice. Water, ice, carbon dioxide, methane, ammonia, volatiles boil. Gas drags dust. You see jets, tails, bright comet head thrust. Material flows one way. Pushing comet the opposite. Newton's third law. Action-reaction. Every comet near the Sun experiences it. One of the first things learned in comet physics. The problem is scale. How much material needs to be ejected to create a certain acceleration? Depends on comet mass, exhaust velocity, jet shape. But for an object the size of 3I Atlas moving at current speed, orbital deviation of 4 arcseconds through perihelion, the number is unambiguous. Requires massive mass loss. Not little, a lot. And here the problem starts. The smoke cloud seen around 3I Atlas measured gas dust, not enough to explain mass loss for the acceleration. There's activity, there's outgassing, but not enough. Not by orders of magnitude. If the acceleration is real, 4 arcseconds telling the truth, the object must have ejected about 5 billion tons of material, possibly more. Conservative estimate. Some models higher. 5 billion tons. To grasp the scale, a typical long-period comet like Hale-Bopp, brightest in recent history, ejected tens of millions of tons of material through perihelion. Maybe 100 million tons if generous. 3I Atlas needs to eject 50 to 100 times more. It would be the most violent outgassing event recorded. And when a comet does that, you see it. You see weeks-long bright outbursts. You see tails millions of kilometers long. You see debris clouds glowing under sunlight reflection and thermal radiation visible from Earth and space telescopes. So where is it? Where is the debris cloud? Where is the gigantic tail? Where are the photometric signs of all that blown-away material? Some observations show brightness increase. Some jets, but nothing near the expectation for 5 billion tons lost. Not even close. And that doesn't match. That's the warning sign. Force without clear cause, acceleration without explanatory reaction mass. Currently a few ways to resolve. Maybe we mistimed the observation. Maybe the cloud is there but hasn't appeared yet. Or orientation hard to see from Earth. Geometry matters. Viewing angle matters. Much unknown about three-dimensional structure around the object. Or material is there but dark. Mostly gas with low dust gas not reflecting much sunlight. Maybe particles too small or transparent not detectable by instruments. Maybe we underestimate stealth capability of debris clouds. But they can accumulate. And each new observation, new spectrum, new image experts narrow possibilities. The door to haven't seen it yet closes, leaving the harder choice assuming the object accelerated without expected mass loss. Maybe doing something we don't understand. Maybe rules for visitors from other star systems are different. And if so, the question is what else is different? Where we went wrong. Because the object changing motion without needing expected reaction mass is not just scientifically odd. It challenges foundational understanding of motion, momentum, material behavior in space. The kind of anomaly that revolutionizes a field or ruins careers trying to explain. Observations continue. Telescopes track the object swinging around the sun heading back into the solar system. November and December 2025 marked on every astronomer's calendar, when 3I Atlas closest to Earth about 19 million kilometers on December 19th, when observation geometry is optimal, when the best chance to see the cloud if it exists. Measure brightness spectrum morphology, answer the question forever, natural comet with extreme properties or something else. But before the December deadline, before what happens next, need to understand the numbers clearly. Put real numbers on the scale. Calculate precisely, see how big the discrepancy is, and what it takes to resolve. Because numbers don't lie. They can be wrong. They can be incomplete, but they don't lie. And the numbers here are staggering. Part 3 quantitative implications affirming this. Talking about momentum. Not the motivational kind, the physics kind. Momentum is mass times velocity. To change momentum, you need force. And if the force is from ejecting material like a rocket, or a comet outgassing, the momentum gained equals the momentum of the ejected stuff. Conservation of momentum. An iron law of physics. No cheating, no negotiation. Just that. So when we say 3I Atlas has non-gravitational acceleration, it means something changed its momentum in a way gravity doesn't explain. And when calculating the amount of material needed to be ejected to create that change, we hit an absurd number based on what we see. Here's the breakdown. Object mass estimated 10 billion to 100 billion kilograms. Just a rough estimate because we don't know exact density size. Could be a few kilometers wide, smaller, larger. Large uncertainty. But let's average about 50 billion kilograms, 50 million tons. A fairly large comet. Observed position deviation near perihelion about 4 arcseconds. In the perihelion pass orbital dynamics, the deviation corresponds to a velocity change of a few meters per second. Assume 5 meters per second as an estimate. Sounds small. 5 meters per second is about walking speed around 11 miles per hour. But for an object 50 million tons mass, a small velocity change requires transmitting huge momentum. When a comet jets gas, the ejected material has a certain velocity relative to the nucleus. Typical comet jets velocities a few hundred to a few thousand meters per second. Assume 1,000 meters per second. Reasonable average estimate, so to change the comet's velocity by 5 meters per second for a 50 million ton comet, an ejected material moving 1,000 meters per second opposite need to eject about 5 billion kilograms of material, i.e., 5 million tons lower bound. If velocity change larger, or exhaust velocity smaller, or comet mass larger, lost mass increases fast. 5 million tons sounds insignificant compared to 50 million tons. Just 10%. But the issue is ejecting 10% of mass over a few days or weeks, not quietly, not invisibly. It creates a spectacular scene. It creates a gigantic, glowing, persistent debris cloud. And when looking at 3I Atlas images from late October, early November 2025, we don't see that scene. But wait, 5 million tons. Earlier said 5 billion tons. Why? Uncertainty in estimates is huge. Comet mass uncertain. Velocity change uncertain. Exhaust velocity uncertain. Some models, depending on assumptions, ejected mass loss up to 5 billion tons or more, 100 times higher. Why the large range? Because physics depends on geometry. If all jets in one direction, maximum efficiency. If random directions need to eject far more material to achieve the same net thrust. If material mostly gas, with low dust content, efficiency changes. If nucleus rotating jets on-off thrust average differently. Truth is, we don't know exactly how much mass loss the acceleration requires, but we know the number is very large. We know much larger than the comet head-tail currently shows, and we know typical solar system comets experiencing non-gravitational acceleration show clear signs of mass loss. Brightness, increased tail extension, dust cloud fragmentation events, all expected from a comet losing a significant portion of mass. Compare to known examples. Comet Hale-Bopp, most active in modern history, ejected about 10 million tons of dust and 100 million tons of gas through perihelion in 1997. Gigantic debris cloud visible to the naked eye for months. Comet Hyakutake, another spectacular visitor, similar activity level. This is the standard. This is normal for highly active comets. If 3I Atlas ejected 5 billion tons, 50 times Hale-Bopp. If it jetted 5 million tons, still on par with large comets. Either way, it should be impressive. Tails millions of kilometers long. Comet head blazing extended. Spectroscopic signs of new volatiles. Even fragmentation nucleus pieces breaking, creating secondary activity sources. All detectable by modern telescopes. All obvious if mass loss occurred on the scale the acceleration shows. And to be fair, some observations show increased activity. Reports of brightness spikes, expanding gas cloud, but still not enough. Not 10, 50, or 100 times depending on the model you trust. Optical brightness, sunlight reflection off dust gas, increased but not dramatically. Tail present but not massive structure. Spectrum shows outgassing but no catastrophic eruption. What are the possible scenarios? First, we might be missing a discrete material cloud. It exists there, but for some reason undetected. Maybe it needs more time to spread and become prominent. Maybe the viewing angle is not optimal, and we're looking from the wrong direction. Maybe the particles are too small, transparent, and scatter little light. This is the natural comet scenario with odd observational traits. This is the safest explanation. It doesn't require changing physics laws, just waiting and more precise measurement. Second, the acceleration really exists, but mass loss is more efficient than predicted. Maybe material ejected at higher velocity than thought. Maybe jets perfectly oriented or targeted to maximize thrust. Maybe special chemical reaction, a form of supervolatile ice sublimating fast without producing much dust. This is the extraordinary comet but still natural scenario. It stretches models but doesn't break them. Third, the acceleration is not from outgassing. Maybe radiation pressure acting on low mass or high reflectivity structure. Maybe plasma interaction with solar wind. Maybe gravitational lensing effect or measurement error making imaginary position deviation while reality has none. This is the we're measuring wrong scenario. This is entirely possible. It has happened before. Science is full of challenges and errors persist, but the measurements have been cross-checked multiple times. The deviation direction is real. The issue is the cause creating it. Fourth, the object accelerates without ejecting mass as expected. It changes momentum through an unknown mechanism, maybe using some propulsion system, maybe exploiting solar magnetic field interaction or solar wind in a way natural objects can't, maybe performing action resembling outgassing but fundamentally different. This is the truly problematic scenario. This is what worries people. Because if true, our entire understanding of comet physics is deficient or worse, deliberately misled. The upcoming measurements in November and December 2025 will rule out options. If a gigantic material cloud appears, first option correct. If super efficient jets with strange chemistry discovered, second option correct. If measurement error or calibration issue found, third option correct. If none of the above, we must face the fourth option. And the fourth option is where things get exciting or scary depending on perspective. But numbers alone aren't enough to describe the full strangeness. Need to discuss the real meaning of this mismatch. Why it's not just a tough puzzle. Why it's a warning signal pointing to something deeper. Something related to the other 9 characteristics, and proving this object doesn't follow the same rules as everything else in interstellar space. Part 4. The deviation of the danger sign. There's a difference between anomaly and deviation. Anomaly is Oumuamua tumbling without a tail. Anomaly is comet with strange composition. Anomaly is low probability orbit. These are things that raise eyebrows, prompt more experiments, publish papers with question marks and titles. But deviation is when fundamental laws are bent, when force and reaction separate, when an object does the impossible according to physics studied throughout a career. The 10th anomaly is the deviation type. And here's why. Every other anomaly, from orbit to composition to brightness, can be explained by extending current knowledge. Maybe the object formed in a special environment. Maybe interstellar travel for millions of years and cosmic radiation altered the surface. Maybe observation geometry at the bright phase makes it look stranger than it is. These explanations require expanding models to cover exceptions, acknowledging the universe is more diverse, but not demanding complete model discard. The acceleration mismatch is different. If 3I Atlas truly changed velocity without ejecting expected mass, then one of the following must be true. Either understanding of momentum conservation is wrong, upending 3 centuries of physics, or the object uses an unseen mechanism. Natural or not, or measurement is wrong. Embarrassing but salvageable. First option absurd. Second option worrisome. Third option is what everyone hopes for. Let's use an example. Imagine watching a rocket launch. Rocket lifts off, accelerates, soars. You know how it works. Burns fuel, pushes hot gas out the back, reaction pushes rocket forward. Newton's third law applies. Now imagine the rocket lifts off. Accelerates, flies high, but no exhaust. No flame, no smoke, no gas. Just the rocket flying higher. Accelerating, you would go crazy. Check instruments. Wonder if hallucinating, because thrust without exhaust is not how physics works. Nothing operates that way. That's what we might be seeing with 3I Atlas. Thrust without exhaust, or exhaust so faint or hidden it's undetectable. And that's why it's a warning signal, making it more alarming than composition or orbit anomalies, because it violates a more basic principle than any specific comet model. Momentum conservation. Push something, it pushes back. Change velocity must throw something opposite. No exceptions, except when there appears to be one. Let's outline the 2 clearest excludable possibilities. Possibility 1, the material cloud is there. We just haven't seen it. Maybe too faint. Maybe edge on and looking through thin dimension. Maybe dark, small particles. Maybe mass loss and a short burst in the cloud expanding, not yet bright enough to detect. This possibility keeps physics laws intact, says the object is a natural comet, albeit extreme, and will understand better with full data. Possibility 2 is no material cloud. The object accelerates through a different mechanism, maybe using solar radiation pressure, though requiring unrealistic area to mass ratio for a solid object. Maybe exploiting solar wind, though, force weak, not creating observed acceleration. Maybe venting dust-free invisible gas to instruments but still carrying momentum. Or maybe the uncomfortable speculation using a propulsion system, a deliberately designed mechanism creating thrust, something artificial. Now before accusing jumping to aliens, let's clarify. Possibility 2 includes many natural options. Strange chemistry, unusual physics, unseen, comet behavior, exception. But it also includes the possibility sitting quietly no one wants to say seriously because it sounds like science fiction. Possibility 3I Atlas is not entirely natural. At least partially designed something out there, made it, and sent it into the solar system. I know how that sounds. Immediate reaction is to dismiss as conspiracy theory. But the issue is this. Science doesn't dismiss possibilities just because they're uncomfortable. Science follows evidence wherever it leads, and tests hypotheses that fit the data. And if the data says no material cloud, must consider what it means. All implications, even the ones that sound like movies. The other anomalies add to the concern. If 3I Atlas only had strange acceleration, could blame measurement or odd outgassing, but it also has hard to predict orbit. Also made from materials unlike normal comets. Also brightens gradually, creating reverse jets. Also came from the direction of a famous unexplained radio signal. Each anomaly alone strange but explainable. All combined with unexpected acceleration, the material cloud starts looking more like pattern than random coincidence. This makes the 10th anomaly the most worrisome. Not just an item on the list. It's the keystone holding the arch. If true, upcoming observations confirm the object accelerated without clear mass loss, then all other anomalies are no longer quirky but clues. Clues pointing to something we're not ready to accept. Something forcing re-examination not just of comet physics but the nature of what we encounter in interstellar space. And that brings to the core issue. Why it matters. Why care about an ice rock from another star system moving off a bit? Because the answer decides what we think is possible. Decides whether alone in a universe of blind natural forces or something else out there watching, traveling, exploring like us. Decides whether physics laws are complete or missing an entire chapter. Decides how we view our place in the universe. So what happens next? What to wait for? And what it means if December observations show no material cloud. Part 5. What is at stake? Why care? Science is not a collection of facts. It is a process of asking questions and accepting answers even if you don't like them. And sometimes that process leads to conclusions that change everything. Sometimes discovering that Earth orbits the Sun, not the other way around. Sometimes discovering that time slows down when moving fast. Sometimes discovering that the universe is expanding and will ultimately die in cold emptiness. No truth is comfortable, but it is truth. Knowing them gives power. The power to predict, understand, and shape reality that doesn't care about comfort. 3I Atlas is such a question. Not because it is certainly artificial, not certain evidence of aliens or an unknown physical phenomenon or anything specific, but because it forces us to confront the limits of what we know. And the answer, whatever it is, pushes those limits one way or another. If continued observations in November and December 2025 show a gigantic material cloud, if 5 billion tons of ejected material is detected mass loss, matching acceleration and everything fits, then this is what we learn. We learn that interstellar objects are more extreme than thought. We learn that comet formation occurs in environments different from the solar system. We learn that the universe creates more diversity than models account for. Still a big deal. It is a comet not in the current catalog, a visitor from an external star system carrying new information about planet formation, star evolution, chemical properties of the interstellar medium. It expands the boundaries of planetary science. It provides new data points, new standards for new objects to study and compare. But if observations show no material cloud acceleration unexplained by visible mass loss, then we are in different territory. Then harder questions arise. Is there a propulsion mechanism we don't understand? A way natural objects increase velocity without losing mass? What interaction between the object and the solar environment creates unseen thrust? Or are we looking at something not entirely natural, something built, designed, sent on a specific orbit for a specific purpose? The implications ripple like cracks in ice. For models of comet formation and evolution, we need to find new physical laws, or accept that some objects follow different rules. For interstellar object research, we realize Oumuamua was perhaps not the strange exception we thought. Perhaps the strange exception is the new norm. Perhaps normal comets are just local domesticated variants while the rest of the galaxy operates on a different script. For planetary defense, the implications are more immediately concerning. Currently, asteroid and comet tracking relies on gravitational models. We calculate orbits decades ahead, predict close approaches with astonishing accuracy, But if objects accelerate, unpredictably change direction without warning or clear cause, then tracking systems have blind spots that can be fatal. You can't defend against something if you can't predict its position. And if 3i Atlas is doing what it seems to be doing, then other objects could too. That's not a comfortable thought when trying to protect a planet full of people who don't think all day about killer space rocks. And then the philosophical, existential direction. For most of human history, we have considered ourselves special, not because better, smarter, more important, but simply because we are here conscious, and as far as we can see, no one else in the universe is paying attention. The silence of the universe is deafening. We have sent signals. We have listened for responses. We have scanned thousands of stars for signs of technology, and found nothing. The universe seems empty, dead, and different. But what if it's not empty? What if the silence is only because we don't know what to listen for? What if the technological signals we're looking for don't look like radio or megastructures, but like objects moving through space in ways natural physics can't explain? What if someone out there is exploring the galaxy the way we plan to, sending probes to collect data, map the neighborhood? And what if 3i Atlas is one of those probes? This is not idle speculation. It is a hypothesis some scientists consider seriously. Not because they want to believe in aliens, not because they abandon natural explanations, but because the data points in a direction that can't be ignored. When you have 9 separate anomalies that shouldn't happen, and a 10th that violates a basic understood physical principle, you at least consider the possibility that you're not looking at a comet. You're looking at something else. For the public, not astronomers or physicists, it carries different meaning. It matters because it challenges the story we tell ourselves about where we are and what's out there. Most live thinking the universe is vast, empty, and we are alone. That assumption shapes everything, how we think about meaning, purpose, the future of humanity. If that assumption is wrong, if we are not alone, if other intelligence out there is sending objects through the solar system, then the entire human story changes. We're no longer the main character, just a supporting actor in a much larger play. And that can be terrifying or exhilarating depending on temperament. So what are we waiting for? We're waiting for light. Photons reflected from dust emitted from gas scattered by debris. We're waiting for telescopes pointed at Atlas in November and December 2025 to capture images that tell us whether the debris cloud exists. Waiting for spectroscopy to reveal what really happened near the nucleus. Waiting for astrometry to confirm or refute the measured acceleration. Waiting for the universe to show its hand. The timeline is clear. The object reaches closest approach to Earth on December 19, 2025. That is the optimal observation window, when instruments like the James Webb Space Telescope, Hubble, ALMA, and ground-based observatories have the best chance to see what is really happening. They will look for specific signs. Expanding dust tail, bright halo, sudden bright points consistent with violent outbursts, new volatile spectral lines, exposure events, fragmentation, radio emissions, anything that shows this is a comet, just a really strange comet. If those signs are found, the mystery is solved. If not, the mystery is deeper and may reshape how we view the universe. And this is worth noting. We don't have to wait long. Observations are happening right now. Data is being collected. By the time you see this, some results may already be in. And the answer, whatever it is, will be the most important scientific discovery of the decade, perhaps the century. So before diving into composition orbit, all the specific anomalies, let's acknowledge the real threat here. It's not just about a comet, it's about a test case for better understanding motion mass, the nature of interstellar visitors. It's about the decision point where science either expands into new territory or reaffirms what we know. And it's about the remote possibility that we are witnessing the first confirmed detection of something from outside the solar system that is not accidental. That's why it matters. That's why the 10th anomaly is not just curiosity, it is a door. And November and December 2025 will reveal what is on the other side. Part 6 detailed chemical composition anomalies. Let's dive into the details. Let's talk about what this thing is actually made of, because the composition is where the strangeness began. Long before anyone noticed the acceleration problem. When we analyzed light from a comet, we split it into wavelengths. The components we observed dark lines where specific molecules absorb specific colors. We are reading a chemical fingerprint. Each molecule has its own signature. Water absorbs here, carbon dioxide absorbs. Their cyanide appears at this wavelength, sodium at that. It's like a barcode telling us what the object is made of. The James Webb Space Telescope pointed its instruments at 3I Atlas in August and September 2025. JWST is designed for this work. Its infrared sensitivity detects molecules invisible to optical telescopes. And what it found no one predicted. The carbon dioxide to water ratio is about 8.1, not a typo. Carbon dioxide is 8 times more abundant than water. To put it in perspective, typical solar system comets have water as the dominant volatile, carbon dioxide a minor component. Ratios are usually 10.1 or 100.1 water to carbon dioxide. 3I Atlas is completely inverted. It is a carbon dioxide comet with a bit of water, not the other way around. Why does this matter? Because water ice is the most common volatile outside the solar system. It is the dominant component in comets, Kuiper Belt objects, icy satellites. The reason is simple. Oxygen is abundant. Hydrogen is abundant. They combine easily into water ice, stable over a wide range of temperatures and pressures. Carbon dioxide is less common because carbon is less abundant than hydrogen. And carbon dioxide ice sublimes at higher temperatures, meaning less stable. For an object to be carbon dioxide rich, it must have formed in an environment where water was suppressed and carbon dioxide enhanced. This is unusual. It suggests formation in a very cold, very carbon-rich region. Perhaps a distant molecular cloud from some star. Perhaps a protoplanetary disk with strange chemical composition. Perhaps a place we don't have good models for. But there's more. The water present at 4% mass is also not normal behavior. Low production rate. The object is active. Yes, it is creating a gas cloud evaporating. But the amount of water vapor released is far less than expected for an object this size at this distance from the Sun. Either the water ice is buried under a thick crust of non-volatile material, or there just wasn't much water to begin with. Both hypotheses are strange. Both require explanations that don't fit normal comet models. Then the polarization problem. When light reflects off a surface or scatters on particles, it becomes polarized. The degree of polarization depends on particle size, shape, composition, viewing angle. Comets usually show positive polarization for most phase angles, meaning reflected light is polarized in a certain direction. However, 3I Atlas shows maximum negative polarization, minimum around 2.7% at a phase angle of 7 degrees. This is unprecedented among known comets. It suggests extremely small particles in the cloud, or unusual refractive index or strange shapes, or all of the above. Polarization is a sensitive tool for surface properties. It can tell what spectroscopy can't. And what it tells about 3I Atlas is that the material surrounding the object is not normal comet dust. It is something else. Perhaps pure carbon dioxide ice particles. Perhaps some kind of interstellar space radiation-formed organic polymer. Perhaps metallic particles of unusual shape. The data doesn't say exactly what, but it clearly says what it's not. It's not the silicate-organic mix seen in every other comet. And then the metals. Initial spectroscopic reports, still preliminary, not fully confirmed, show unusual metal ratios. Specifically, nickel appears enhanced relative to iron. Solar system comets have nickel to iron in the cosmic abundance ratio, about 1 nickel to 16 iron. However, some 3I Atlas observations show a ratio close to 1.1 or even nickel dominant. If true, and this is a big if because signal to noise is low, and analysis is ongoing, then it is extremely strange. Nickel-rich alloys are not something expected to condense naturally in a protoplanetary disk. It resembles something seen in processed industrial alloy material, refined metals. Before anyone runs off building conspiracy theories, let's be clear, this metal measurement is not confirmed. It could be an instrumental artifact. It could be contamination from something else in the line of sight. It could be misinterpretation of a spectral feature that looks like nickel but is something else. The scientific process demands skepticism, especially for extraordinary claims. But the fact that this signal is even being discussed, the fact that reputable scientists are taking it seriously enough to publish papers calling for follow-up observations, shows how far outside the norm this object lies. So what explains this composition? Let's consider possibilities from the most ordinary to the most speculative. First, the object formed in a cold, carbon-rich environment far from some star. An interstellar molecular cloud could have unusual chemical composition. If 3I Atlas condensed in one area of that, it could have more carbon dioxide, less water than normal solar system comets. Cosmic radiation over millions or billions of years could alter the surface, creating unusual polarization signatures. This is a natural explanation. It doesn't require new physics, just an unfamiliar environment. Second, the object is an ice dwarf from the outer regions of another star system. Some models suggest planetary systems can eject large numbers of small bodies during formation, flinging them into interstellar space. If 3I Atlas came from a star system rich in different elements or with a different thermal history, its composition would reflect that difference. This is still reasonably natural, though it forces us to expand planet formation frameworks to embrace far greater chemical diversity than ever before. Third, the object may have endured violent degradation from interstellar radiation and cosmic rays. After millions of years wandering the galaxy, those high-energy particles tear apart molecules, create strange compounds, completely transform the outer shell. Perhaps what we're seeing is the result of that torture, a pristine water-ice comet now transformed into something entirely different under the harsh hand of interstellar space. This explanation is strangely compelling, because it both explains the anomaly and preserves natural origin. Fourth, and here we step into dreamland, that composition could be a trace of manufactured origin. If you were building a star-crossing machine, you wouldn't choose water ice as the primary material. You'd want something more stable, something that doesn't easily sublimate, something that can withstand extreme temperature changes and intense radiation. Carbon dioxide ice is actually an ideal candidate for propellant or coolant because it sublimes cleanly without leaving residue. Nickel alloys are aerospace engineering standard for durability, heat resistance, and lightness. If 3I Atlas is a manufactured product, its composition would make far more sense than a natural object. But here's the sharp warning: chemistry alone proves nothing. Weird chemistry can arise naturally. The universe is full of environments we don't understand, processes we haven't modeled, exceptions that produce unexpected results. You can't look at an inverted carbon dioxide to water ratio and jump to aliens molded it. Science doesn't work that way. You need independent stacking evidence. You must first rule out every natural explanation. You need to prove not just strange but impossible without intervention. And that's why the composition anomalies are just pieces in a much larger picture, not the sole answer. They are notes in a symphony that includes anomalous orbit brightening behavior and the climax of acceleration without visible debris. Each piece alone is strange. All together they start to paint a pattern, and that pattern forces you to stop and think. The lesson from the composition analysis is that 3I Atlas is not a normal comet. It is not made from the same stuff. It does not operate on the same script, and it doesn't fit any existing catalog, whether because it formed in an unusually distant place or was transformed during a long journey, or because its nature is fundamentally different from a comet we don't yet know. But the chemistry is waving a red flag. And when you connect the chemical signal to the dynamical signal, you have a situation that demands deeper scrutiny. So let's explore this object's path together. Let's dissect the orbit, the timing, and the uncomfortable coincidences that pile up when you look more closely. Part 7: Orbit Timing and Strange Fine-Tuning. Orbit is destiny in space. Where you come from, where you've been, the speed you're going, all encoded in the orbital equation. And orbits never lie. They are shaped by gravity, momentum, the initial conditions when the object was born or released. You read an orbit like an epic poem. It tells origin, encounters, future destination. And 3I Atlas's orbit is whispering a story that is not entirely coherent. The object entered on a hyperbolic orbit with eccentricity greater than 1, the mathematical signature of interstellar origin. It is not bound to the sun. It is just passing through. Inclination about 175 degrees, meaning retrograde to the planetary orbits. This is not surprising for an interstellar visitor. No reason an object from another system should follow the solar system's direction. It should arrive at a random angle, except this angle is not random. The orbit is nearly parallel to the ecliptic plane within 5 degrees. Sounds close enough, and it is geometrically. But here's the problem. If the object came from a random direction in 3-dimensional space, the probability of accidentally aligning with a specific plane is extremely low. Calculations show about 0.2% 1 in 500. Not impossible, but not a probability to bet on. Some experts argue it's just selection bias. Surveys like ATLAS are more sensitive to objects crossing the ecliptic plane because that's the region we focus observations on. If you're looking for near-Earth asteroids, you point where asteroids congregate, i.e., near the ecliptic plane, so perhaps we are more likely to detect interstellar objects passing through that region, even if they are no more common from other angles. Fair point. Methodological concern is valid, but it doesn't explain the full degree of alignment, because even after correcting for bias, the alignment is still uncomfortably precise. Then there's the timing. 3I Atlas skimmed near Mars on October 4, 2025. No collision, not even close by cosmic standards, but close enough for Mars's gravity to perturb the orbit slightly. Then it slid past Venus a few days later. October 10th then reached perihelion on October 29th, finally flying near Jupiter's orbit in early November. 4 major solar system bodies encountered in just a few weeks. What is that probability? Some researchers ran simulations, generated thousands of random interstellar orbits, sent them through the solar system, counted how many coincidentally came close to multiple planets in sequence. The number depends on the definition of close, but with a reasonable definition, the probability is about 0.005% 1 in 20,000. Again, not impossible, but add the ecliptic alignment and you multiply small probabilities. And multiplying small probabilities yields extremely small probabilities. Now, speculation begins. A.V. the Harvard astronomer, famous for being willing to consider artificial origin for interstellar objects, pointed out that 3I Atlas's orbit looks optimized. If you wanted to survey the inner solar system, fly near Mars, near Venus, get a close look at the Sun, then cut across Jupiter on the way out, you would design an orbit very much like this. You'd aim for the ecliptic plane because that's where the interesting stuff is. You'd time it for maximum close approaches. You'd use gravity assist to adjust the path, exactly what we do when designing missions to explore other planets. The strong counter-argument is that with enough objects, rare events will happen. If thousands or millions of interstellar visitors pass through the solar system over time, and we only detect 3, then the detected objects will be strange. They will be the ones close enough to Earth to see. They will have orbits that bring them into the inner system where telescopes look. Selection effect creates the illusion of impossibility when you don't account for the unseen objects. Also true, but other details make the orbit more suspicious. The object reached perihelion just 8 days after solar conjunction, meaning it was obscured from Earth during its closest approach. For about 2 weeks from mid-October to early November 3rd, Atlas was in a region unobservable from Earth telescopes. The Sun was in the way. In perihelion, the time when a comet is most active, heating up, releasing gas, performing the comet miracles, it usually does happen during that lights-out period. Coincidence? Maybe. The Sun is a big object. It occupies a significant portion of the sky. Any object close will be unobservable for some time. But the timing is extremely convenient if you want to avoid scrutiny. If you want to do something near the Sun without being detected, you do it during conjunction, wait for Earth to be on the opposite side. And 3I Atlas did exactly that. I'm not saying it proves anything. Just saying another data point that fits a pattern that seems impossible but still happens. And when facing 10 anomalies, you wonder when the pattern stops being random coincidence and becomes a signal. Where's the threshold? How many low probability events before you seriously consider they are not independent? Maybe related, maybe there's a reason behind them. The orbital anomalies further push the acceleration mystery. If 3I Atlas only moves strangely, you could blame measurement strange outgassing or randomness. But moving strangely aligning with multiple planets when easy to observe plane scheduling. So the interesting part of the journey is hidden. That's a lot of ifs, a lot of fine-tuning. And fine-tuning in nature usually has an explanation. Either a selection mechanism at work causing traits to cluster, or a designer choosing traits deliberately leading to brightness jets, making the object less like a normal comet, more like something operating on a different script. Part 8. Sunward jets anti-tail behavior. Comets get brighter when closer to the Sun. One of the few universal rules. The closer to the heat source, the more ice sublimes. The more material escapes, the more light is reflected. Brightness usually scales as a power law with distance from the sun. Comets are expected to brighten by a factor of 10 for every 3-fold decrease in distance to the sun. Completely predictable. Follows a curve astronomers model accurately and reasonably. 3I Atlas does not follow that curve. It brightened faster than any known comet. From August to October 2025, approaching perihelion, optical brightness increased by several magnitudes in just a few weeks. Truly explosive. The kind of brightening seen in nucleus fragmentation events where the core breaks, exposing fresh ice to sunlight. But no evidence of fragmentation. The object appears intact. So what caused the sudden brightness spike? And here's the stranger part. The color changed. Comets are usually red, especially near the sun because dust dominates the reflected light. Dust is usually red. Silicates, organic material, iron oxides. Materials that absorb blue and reflect red, but 3I Atlas shifted greener than the sun. Truly counterintuitive. Against what should happen. Blue light means reflection or emission at shorter wavelengths, suggesting very small particles, very hot gas, or surface properties that prefer blue over red. One explanation is gas-dominated coma, not dust. If the emission is mainly from carbon dioxide without producing much dust, the light seen is molecular gas fluorescence, not sunlight reflection off particles. Gas fluorescence can be blue. Carbon dioxide ionized by solar UV emits at specific blue wavelengths, so perhaps we're seeing a gas-rich, dust-poor comet. Sounds unusual but not impossible. Another explanation is a high albedo smooth surface like ice without rock. Freshly exposed ice is very bright, slightly blue because it scatters short wavelengths efficiently. Perhaps brightening due to large surface ice patches suddenly exposed, or sublimation removing upper crust or some surface regeneration process. Again unusual but not impossible. But then the antimatter problem. Comet tails point away from the sun. Always. Basic physics. Solar wind radiation pressure push gas and dust away from the sun, creating the tail. Sometimes an illusion anti-tail shape makes the tail look sunward, really just projection effect. Looking at the tail edge, the brain is tricked. 3I Atlas observations show real material streams toward the sun. Material pushed toward the sun, or at least not away from the sun. Observations from July and August 2025 before perihelion, when the object was still far out on the edge. Material streams not anti-sunward are rare but not unprecedented. Can happen if the nucleus is rotating with active regions on the wrong side, or some obscuration effect or material ejected with velocity high enough to overcome radiation pressure. But quite unusual. Combined with everything else, it adds to the feeling that the object is not following the rules. So let's reflect on the meaning of these observations. The explosive blue light. Oh my, the sunward jets. If we try to model it as a natural comet, we need to invoke many special conditions. Low dust content, high gas production. Unusual surface properties, strangely placed active regions. Entirely possible. We can build a model that fits, but it requires stretching parameters to the maximum, assuming exceptions in every variable. It fits the data but is not comfortable. If we try to model something artificial, an object deliberately using controlled outgassing to create observed thrust, it makes more sense. We expect jets that do not follow standard comet geometry because they are not controlled by solar heat. We expect gas-dominated exhaust because dust is inefficient if you want maximum thrust per unit mass. We expect rapid brightness changes because turning jets on and off is needed. We expect blue color if the propellant is carbon dioxide or another volatile that emits in blue wavelengths. Each strange feature becomes a design choice, not a natural accident. But again, emphasizing that being able to model something artificial does not mean it is artificial. It only means the artificial hypothesis fits the data better, or even much better than the natural hypothesis. And science does not choose hypotheses based on which fits best. It chooses based on which a hypothesis makes testable predictions and is more parsimonious. Natural origin is parsimonious because we know natural objects exist. Artificial origin requires the existence of something unconfirmed. extraterrestrial intelligence capable of sending probes across interstellar distances. A much larger claim. It demands much stronger evidence. So what does this mean for us? We are left with a series of observations that fit an unusual natural comet but also fit something purposeful even better. And the way to distinguish those possibilities is to look at the physics, measure the acceleration, calculate each force, see if the numbers add up or not. This brings us to astrometry gravitational lensing. Alternative explanations for why the object is moving the way it is. Part 9, Astrometry Gravitational Lensing. Alternative explanations. Astrometry is the art of measuring the position of objects in the sky with extraordinary precision. We are talking about determining the position of an object millions of kilometers away to within arcseconds. To visualize, an arcsecond is equivalent to the size of a quarter coin seen from 4 kilometers away. Such precise measurements require extremely stable telescopes, careful calibration, sophisticated data analysis. But when done right, astrometry gives not just position but how it moves, and how it moves tells what forces are acting on it. The Atacama Large Millimeter Submillimeter Array ALMA is the best instrument for this job, a system of 66 radio antennas in the Chilean desert working together to create an effective telescope the size of a city. When ALMA pointed at 3I Atlas near perihelion, it measured the object's position against background stars and comets. And comparing that measurement to the predicted position based on a gravity-only model, there was a difference of about 4 arcseconds. A large number in astronomical terms. It is a canyon. But before concluding, we need to consider every possible source of error. One thing to consider first is gravitational lensing. When light passes near a massive object like the sun's spacetime curves, and the light follows that curve. General relativity at work. Einstein predicted it. Solar eclipse observations confirmed it, now a standard tool in astrophysics. The deflection depends on how close the light passes to the sun and the sun's mass. Light grazing the sun's edge deflects by about 1.75 arcseconds. Light passing farther deflects inversely with distance. So when 3I Atlas passed near perihelion, any light reflected from it to Earth was bent by the sun's gravity. That bending shifts the apparent position of the object. The question is how much shift? Using the standard formula for geometric deflection, 3I Atlas at perihelion had about 0.27 arcseconds of angular deflection from the sun. The object at perihelion was very close to the sun in angular terms, so the lensing effect is significant but not 4 arcseconds, perhaps at most a fraction of an arcsecond. The measured deflection is larger by orders of magnitude than lensing can explain. Could it be measurement error? Instrument miscalibrated, data analysis flawed? Certainly possible. Astronomical measurements are hard. There are systematic errors. Atmospheric distortion instrument drift all kinds of errors that creep into data, but ALMA is a professional facility. The data is cross-checked. The analysis is peer-reviewed. If there is error, it is very small. Small errors usually do not create 4 arcsecond deflections. They create uncertainties of fractions of an arcsecond. So if not lensing, not measurement error, what is left? Non-gravitational acceleration. Some force besides gravity pushing or pulling the object, changing its orbit, manifesting as position deviation. And the natural candidate for that force is outgassing. Material pushed out of the comet creating thrust, changing the orbit. As discussed, the problem is the amount of outgassing needed to create. The observed deviation is very large and we do not see the debris cloud that should accompany it. But perhaps another mechanism. Let's explore them. First, radiation pressure. Sunlight carries momentum. Photons hitting a surface create a very small force. For a very light object with large surface area, like a solar sail, radiation pressure is significant. Is 3I Atlas light enough for effective area large enough to be accelerated by sunlight? The numbers in practice are not. A nucleus, a few kilometers across, made of rock and ice, radiation pressure force is very small compared to gravity. You need something like a thin metal sheet to get significant acceleration from sunlight alone. And observations show 3I Atlases, a solid object, not a thin sail. Second, the Yarkovsky effect. A thermal tug that affects small asteroids. The basic idea is the sunlit side of the object heats up. As the object rotates, the hot side moves into the dark cools and emits infrared radiation. The emitted radiation carries momentum, creating a small thrust. Over long periods, it changes the orbit of the object, but the Yarkovsky effect is really weak. It only matters for asteroid-sized bodies over millions of years. For a comet-sized object over a few months, the acceleration is negligible, too small to explain a 4 arc-second deviation. Third, plasma interaction. The solar wind is a stream of charged particles flowing out from the sun. If the object has a magnetic field or ionized outgassing, there could be electromagnetic interaction between the object and the solar wind. Could that create force? In principle, yes. In practice, the force is very small unless the object has a very strong magnetic field or creates a huge amount of ionized gas. No evidence 3I Atlas has a magnetic field. The observed ionized gas is not that large, so plasma interaction is hard to be the answer. Fourth, some kind of strange supervolatile. Maybe the object contains hypervolatile ice material that sublimes at very low temperatures, creating high-velocity water jets. For example, hydrogen ice, helium ice. Such things are invisible to most instruments because they do not emit in optical wavelengths and do not create dust. They create thrust without visible debris. The problem is hydrogen and helium ice are extremely hard to retain. They sublime at temperatures near absolute zero. Even in the coldest interstellar molecular clouds, retaining bulk ice of this for millions of years is challenging. And near a star it vanishes in seconds. So while a creative idea, it is not convincing upon closer look. Fifth, at this point in speculation, perhaps the object is using some kind of propulsion system we do not understand. Not a rocket, not outgassing in the usual sense, but something else. A sail that captures solar wind more efficiently. A magnetic scoop that pulls in charged particles and ejects them for thrust. An engine based on physics not yet discovered. The realm of we do not know what we do not know. Not satisfying because it does not provide a mechanism, but honest. Saying, given the observations, given the lack of a fitting natural explanation, we must consider the possibility that something new is happening. Upcoming observations in November and December are designed to test these options. If radiation pressure or thermal effect is the cause of acceleration, it will continue in a predictable way. If outgassing is the cause, we will see the debris cloud linked to the thrust and mass loss. If something strange, we will see unexpected signs. Radio emissions, anomalous magnetic fields, polarization. The data will narrow the range. But what if no natural mechanism fits? What if there is still acceleration unexplained by known physics? Then speculation becomes serious. Then we ask the question no one wants to say, but everyone thinks, is this intentional? Part 10, speculating on something more intentional. Hypothesis. The point where we cross the line. Up to now, everything described is based on observations, measurements, published papers. Strange, yes, but recorded. Now we talk about more speculative possibilities, ideas not proven, not confirmed, but suggested by the data. If speculation makes you uncomfortable, I understand. Science is conservative, cautious, skeptical, but science follows evidence, and sometimes evidence only points to answers that sound fictional. So let's lay out a decision tree. If the November and December observations detect a gigantic material cloud, if 5 billion tons of ejected material appears, then everything is clear. 3I Atlasis, a natural comet, the most extreme ever recorded, but still natural. It formed in a different environment. Strange composition. It behaves oddly because it came from outside the solar system and the rules there are different. The mystery dissolves. We write the paper. Update the models. Move on. Science wins. But if observations show no material cloud, if the acceleration persists without clear, then trouble arrives. Trouble that forces considering unwanted options. Option 1, we measured wrong. The deviation is real but not acceleration. Perhaps parallax geometry, an undetected instrument artifact. This is the hypothesis that we made a mistake. Embarrassing, but it happens. Science is done by humans. Humans make mistakes. If this is the answer, it will eventually be found. Someone finds the bug in the code, or the calibration of the system, and everyone breathes a sigh of relief. Option 2. An unknown natural mechanism. A strange physical phenomenon, unusual chemistry interaction between the object and the environment creating thrust without visible debris. Perhaps venting supervolatile we cannot detect. Perhaps using radiation pressure in a way not imagined. Perhaps a new force effect only apparent under certain conditions. This is the new physics hypothesis. Exciting, but it requires expanding theory. It means rewriting textbooks. It means admitting the universe is stranger than models explain. Option 3. The object is artificial design manufactured launched on a specific orbit for a specific purpose. This is the hypothesis that makes people uncomfortable because it implies intelligence. It implies technology. It implies we are not alone, and someone out there has superior capability. Let me be clear, I am not saying option 3 is correct, only that it is still under consideration. It fits the data, and science does not dismiss a hypothesis just because it is socially awkward. Let's explore what option 3 would mean. If Atlas is a probe, a spacecraft, a manufactured object, then many things make sense. The orbit makes sense. You want to fly near Mars to study it. Fly near Venus. Perihelion close to observe the Sun. You design the path for maximum scientific benefit just like we do with solar system exploration missions. The timing makes sense. Arrive when planets are aligned favorably. Use gravity assists if available. Optimize fuel and time. The composition makes sense. You do not build a probe out of water ice. Water is reactive, freezes, expands, not stable long term. You use materials that withstand temperature changes and radiation. Carbon dioxide ice is not a bad choice for propellant because it is stable when cold, sublimes cleanly when hot. Nickel alloys are aerospace standard. Low water content, unusual metal ratios are engineering choices more than natural formation. The acceleration makes sense. Use perihelion to adjust orbit. Activate a thruster, deploy a sail, use whatever propulsion system you have. Do it during solar conjunction when Earth cannot see not to hide, but because geometry is optimal. No visible debris cloud makes sense because you do not vent gas randomly. You control thrust precisely, use just enough propellant to perform the maneuver, no wasteful, spectacular tail. Brightening jets make sense. You expect brightness changes as systems activate. You expect jets not following natural geometry because they are controlled. You expect gas-dominated exhaust dust is inefficient if you want maximum thrust per unit mass. Every anomaly, every strange feature is explainable if you assume deliberate design instead of random natural processes. The problem is applying a hypothesis to data does not make it true. I think anyone can explain anything if creative enough. Testing a hypothesis is not about fitting observations. Testing is about making predictions that can be tested that make alternative explanations less likely. So what would confirm 3i Atlasis artificial? First, rule out every natural explanation. Prove beyond doubt that no combination of strange chemistry, unusual physics, exceptional conditions can create the observed behavior. Really hard. Nature is diverse. There's always a rare script, a lucky coincidence. But if enough natural explanations fail the parameter, space narrows, nothing left, then you start seriously considering the alternative. Second need. Positive evidence of design patterns too regular for nature. Signals carrying information structures showing engineering principles, modulated brightness emissions resembling communication control, spectral signs of artificial materials, things like industrial polymers, refined metals not found in nature. Nothing like that found yet, but still looking. Third need, independent confirmation. 1 anomalous object. 2 objects with similar characteristics make a pattern. 3 objects make a phenomenon. If 3i Atlasis artificial, it is probably not unique. There must be others. Perhaps we have seen them and not recognized. Perhaps Oumuamua was one. Who knows, the next interstellar visitor will have similar characteristics. If we start finding multiple objects with these traits, the artificial hypothesis becomes much stronger. But let's talk counter-arguments because there are good reasons for skepticism. First, the vast majority of scientists favor natural explanations. Not because they are narrow-minded or fear implications, but natural explanations have a much better track record. Every time in history we encountered something strange, from comets to pulsars to fast radio bursts, the answer was always natural. Never aliens. Strong prior. You invoke intelligence only after trying everything else. Second, interstellar travel is really hard. Really hard. Distances are vast. Timescales are long. Energy requirements are huge. Even moving at a significant fraction of light speed takes decades, centuries. And 3I Atlas is not moving that fast. It is moving about 30 kilometers per second, fast by human standards but glacial by interstellar standards. At that speed, it takes tens of thousands of years to travel from the nearest star. Why send a probe on a journey longer than most civilizations? Why not wait for better technology, send signals instead, or stay home? Third, if probes are flying through the solar system, we should see more. We have been seriously observing the sky for a few decades. Catalogued hundreds of thousands of asteroids and comets, found exactly 3 interstellar objects. If one is artificial, the detection rate is 33%. That number is too high. Unless probes are extremely common, unless the galaxy is teeming, the chance of accidentally detecting a probe in the first few years of searching is tiny. These are reasonable counter-arguments, reasons most scientists are not rushing to embrace the artificial hypothesis, but not conclusive. Arguments based on probability, not evidence. And sometimes the improbable happens. Sometimes the universe surprises. The question is how much evidence is needed before seriously considering an uncomfortable idea. Astronomer Avi, mentioned earlier, argues we should at least investigate this possibility. The view is not that 3I Atlas is definitely artificial. The view is not to dismiss the idea without looking carefully. Collect data, test predictions, let evidence lead. If natural, great. We learn about strange comets. But if something else, if we ignore clues too embarrassing to consider the consequences of failure as scientists. To let bias blind discovery. And here is the uncomfortable truth. If a probe from another civilization is traveling the galaxy, studying solar systems, collecting data, we would expect it to look like 3I Atlas, small, fast, strange orbit, strange activity near the star. We would not expect it to broadcast its presence. We would not expect it to land on Earth and introduce itself. We would expect it to do exactly what our probes do. Observe, measure, move on. And if we encounter such a case, we will probably argue for years, evidence compelling but not conclusive. Ambiguous enough that skeptics still skeptical, believers still curious. That is the current situation. The 10th anomaly, acceleration without debris, is the tipping point. If true, if December shows no debris cloud, the artificial hypothesis moves from fringe speculation to serious consideration. Not certainty, not proof, but a hypothesis that needs attention. And if you think searching for extraterrestrial intelligence is worth doing, if you think knowing whether we are alone or not matters, then this object is the most important target we are pursuing. So let's widen the view, connect the story to the broader context of recent discoveries. Ask what else is happening in 2025 that makes 3I Atlas part of a larger pattern. Part 11, Recent Astronomy News. First, surprise exoplanet atmospheres. While busy tracking the interstellar visitor close to home, astronomers studying other star systems found their own surprises. In September 2025, a research team using the James Webb Space Telescope announced the discovery of an exoplanet atmosphere completely different from what current models predict. The planet, named WASP 243b, orbits a Sun-like star about 400 light-years away. It is a hot Jupiter, a gas giant planet orbiting its star tidally locked one side, always facing the heat. Standard models predict an atmosphere mostly hydrogen and helium, with some water, carbon monoxide, perhaps some methane, ammonia. But the atmosphere of WASP 243b is mostly carbon dioxide, nearly 50% carbon dioxide by volume. Water content is negligible. Hydrogen and helium are there, but not the dominant components. The spectrum shows molecular features that do not match any known atmospheres in the solar system or theoretical models for hot Jupiter formation. Either the planet condensed in an environment much richer in carbon than oxygen, or some process removed hydrogen concentrating carbon dioxide. Either way, it is wrong. It should not exist. The research team published in Nature. The exoplanet community reacted with excitement and confusion. Excitement because a new data point, a new type of world expands understanding of planetary diversity. Confusion because no one has a satisfactory explanation for how such an atmosphere is created. The leading hypothesis is the planet formed farther from the star in a region rich in carbon dioxide ice than migrated inward, but it does not fully explain such extreme ratios. It does not explain why hydrogen and helium are not dominant despite being the most abundant elements in the universe. So what does this have to do with 3I Atlas on the surface? Nothing at all. One is an interstellar visitor to the solar system. The other is an exoplanet atmosphere hundreds of light years away. But the themes are related. Both are examples of the universe creating things that do not fit models. Both are exceptions that challenge assumptions about composition and formation. Both force astronomers to face the uncomfortable possibility that theories are incomplete. For decades, we built planet formation models based primarily on observations of our own solar system. What we see here is typical other systems look similar, different, but the more we explore exoplanets, the more we realize how unusual the solar system might be. According to early models, hot Jupiters should not exist. Super-Earths in tight orbits should not exist. Giant ice planets in retrograde orbits should not exist. And now carbon dioxide-dominated atmospheres should not exist. Yet they all do. The lesson is humbling. The universe is not obliged to follow expectations. Formation processes are complex. Environments are diverse, exceptions are more common than thought. When you consider billions of star systems, each with its own history, its own chemical signature, the parameter space is enormous. Some regions create familiar results. Other regions create results that look strange but are perfectly natural under those conditions. So when we look at 3I Atlas and see carbon dioxide-rich composition and scratch our heads, perhaps we should not be surprised. Perhaps such objects are common in certain stellar environments, the same environments that create strange exoplanet atmospheres. Perhaps finding both strange interstellar objects and strange exoplanet atmospheres in the same year is not random coincidence but a signal. A signal that the universe hides more mysteries than imagined. It does not mean 3I Atlas is obvious. It does not prove anything, but it provides context. It reminds that strange is gradually becoming the norm in astronomy. Every new instrument, every new survey finds something that does not fit the textbook. Perhaps the horror before the three characteristics of Atlas should be soothed by admitting the universe is full of surprises. Some natural, some not. The only way to know is to keep searching, measuring, testing. And speaking of testing, there's another frontier in 2025 that brought breakthroughs. The frontier of fundamental physics, where scientists use the universe as a laboratory to probe the limits of theory. Part 12. Recent physics news testing general relativity progress in gravitational lensing. In March 2025, a team of physicists announced results from the most precise solar lensing experiment ever, using a network of telescopes around Earth to measure starlight deflection near the Sun during a partial eclipse. The technique is basically the same as used in 1919 to confirm Einstein's general relativity, but modern instruments' data analysis are thousands of times more precise. The result, general relativity, is correct to within 1 part in 10 million. The measured deflection matches Einstein's prediction. No deviation, no anomalies, no signs of modified gravity. Extraspatial dimensions, alternative theories. Strange theorists proposed for years. The Sun bends spacetime exactly as it should. The universe, at least in this corner, under these conditions, follows the rules. Sounds boring. Scientists confirming something we already knew is still true. But it is actually profound because every test of general relativity is a chance for the theory to fail. Every measurement is a potential crack in the foundation. The fact that GR keeps passing tests decade after decade with ever-increasing precision shows that whatever the ultimate theory of quantum gravity is, it must reduce to general relativity in the classical limit. Einstein got the nature of spacetime very right, but here is the point related to 3I Atlas. An initial analysis of the object's orbit noted that solar gravitational lensing shifts the apparent position by a small but measurable amount. The formula is simple. The deflection angle is 4 times the gravitational constant times the Sun's mass divided by the speed of light, squared times the impact parameter geometry. For 3I Atlas at perihelion, The predicted lensing deflection is about 0.27 arcseconds per degree of angular separation from the Sun's center, a small number but not zero, much smaller than the 4 arcsecond deviation observed, meaning lensing does not explain the position anomaly. This deviation is real, due to some cause other than space-time curvature near the Sun, perhaps non-gravitational acceleration measurement error, something not thought of but not lensing. Important because it rules out a plausible explanation. It narrows the range, provides a test case. If 3I Atlas's motion is truly anomalous, if the acceleration is real, then a rare opportunity to test physics on an interstellar traveler. Measure the gravitational influence on the object from outside the solar system. Check if the gravitational constant for interstellar matter is the same as solar system matter. Look for small deviations suggesting new physics fields. So far, no such deviations. The gravitational deflection matches predictions. The orbit follows Newtonian mechanics plus relativistic corrections exactly as expected, except for the non-gravitational component, meaning whatever is causing the acceleration is not a reduction in gravitational force. It is something else. This suggests an interesting philosophical perspective. We live in a universe governed by laws. Those laws, as far as we know, are universal. They operate the same way everywhere, every time. The force of gravity on Earth is identical to the force of gravity near a distant quasar. The speed of light is constant whether in a lab or intergalactic space. This universality is the foundation of physics. It is why we can make predictions, send probes to other planets, know they will arrive where calculated. But what if the laws are not universal? What if in regions of space types of matter conditions the rules change? What if interstellar objects from certain environments behave differently because they formed under different physical regimes? Sounds far-fetched but entirely testable. Compare objects from many different origins, see if they follow the same equations or not. So far, that's right. 3I Atlas, despite its strangeness, still obeys. Gravity still obeys the law of conservation of momentum, at least meaning that if it accelerates, something must provide the force. The question is what creates this force, and the December observations hope to answer that question. Either we see the debris cloud confirming outgassing as the mechanism, or we don't see it and must consider less favorable alternative options. But whatever the answer is, it limits the physics laws we understand. Unless those laws turn out to be incomplete, which in its own way is even more exciting than finding an alien probe. Now let's switch topics to human technology. Because while we're studying the interstellar visitor, we ourselves are becoming an interstellar civilization, and the parallels are astonishing. Part 13 Recent Space Technology News. Commercial spacecraft skims the Sun thanks to solar sail propulsion system. In August 2020, a private space company named Helidine successfully demonstrated a spacecraft skimming the Sun within 10 million kilometers of the Sun. The mission, named Project Icarus II, used a reflective sail with a diameter of 50 meters to harness solar radiation pressure. As the spacecraft approached the Sun, the light intensity increased. The sail captured that momentum, accelerating the probe to over 100 kilometers per second. Really fast, a significant fraction of escape velocity from the solar system. The mission's purpose was to test the concept of a propulsion engine for future interstellar probes. The idea is simple: use the Sun as a slingshot. Get close, unfurl. The sail receive the intense radiation and sling out. No rockets, no fuel, just photons and physics. Elegant, efficient, and it worked well. Project Icarus II is now on a trajectory that will take it completely out of the solar system, becoming the 5th human-made interstellar object after Voyager 1, Voyager 2, Pioneer 10, and New Horizons. The mission has generated huge excitement in the space community. It proves solar sails are viable for deep space exploration. It proves you can achieve high speeds without carrying large amounts of propellant. And it opens the door to serious discussion about sending probes to other star systems within human lifetimes. Not crude interstellar colonization, not rudimentary missions, but small, fast probes, reaching nearby stars in a few decades instead of millennia. Now think about the meaning of this in the context of 3I Atlas. We are developing technology to send objects on orbits that fly close to the Sun and accelerate toward interstellar space. Those objects would look a lot like comets from an external observer's viewpoint. approaching the sun. Brightening due to sunlight reflection, undergoing acceleration near perihelion from the sail or jet engine. And if you didn't know it was artificial, if you just saw a faint hyperbolic orbit, you might classify it as an unusual comet. The comparison is not perfect. Project Icarus II has a thin sail, not a solid object. No comet-like nucleus or typical comet features, but the concept is quite similar. It's an object using solar energy to change its orbit. And if we are doing this in 2025 with limited technology and resources, what is a more advanced civilization doing? What do their probes look like? Perhaps using a combination of sails and outgassing. Perhaps carrying propellant like carbon dioxide ice that serves as both coolant and thrust fuel. Perhaps coating the probe with materials that reflect light in unusual ways, creating polarization signatures unlike natural objects. Perhaps designing orbits to maximize close approaches to interesting planets using gravity, assist to optimize fuel burn. In other words, perhaps manufacturing something that looks a lot like 3I Atlas. It doesn't prove anything, but it shows the artificial hypothesis is not absurd. It doesn't require impossible physics magic. It requires technology just a few steps ahead of what we have. And if we reach this level in a few thousand years, imagine what a civilization a million years ahead can do. The gap between us and them is greater than the gap between us and bacteria. Their probes could be crafted with astonishing precision, fine-tuned to blend almost perfectly into the natural flow of the universe, revealing themselves only through tiny cracks like superior acceleration, deviant chemical composition, or trajectories that seem too artfully arranged. Another discovery from Project Icarus II affirms that solar skims are now everyday reality. They are no longer science fiction dreams. They are pure engineering, and that implies that when we witness an object performing such a skim, we cannot hastily assign it to natural phenomena just because it reminds us of familiar comet behavior. Comets outgas near the sun. Solar sails accelerate near the sun. Both produce similar observational signatures to the point of confusion. Classification requires meticulous dissection patience, and sometimes those details dangle unclear. So we watch, measure, wait for December with rising anticipation. And while waiting, we push our own technology, overcome self-imposed barriers, transform into the kind of civilization that one day can launch probes to distant stars. Everyone recognizes the irony. We hunt for signs of extraterrestrial intelligence while turning ourselves into living proof of that intelligence. If someone out there is watching us the way we are watching 3I Atlas, perhaps they are struggling with a similar debate. Is it natural or artificial? Should we dig deeper or just call it another cosmic oddity in a universe full of surprises? Let's dig into one more latest technology news because it hits right at how we track objects like 3D Atlas and the implications for tomorrow. Part 14, Recent AI Computing Breakthroughs. News Item 4. AI assists in asteroid and comet tracking, detects anomalies. In June 2025, the European Space Agency deployed an AI system named Sentinel AI to monitor small bodies in the solar system. The system uses machine learning algorithms trained on decades of asteroid and comet observation experience to identify anomalies in real time. When survey telescopes catch a new object, Sentinel AI analyzes orbit brightness spectrum morphology. The system compares features to known populations. And if the object has unexpected unusual characteristics, the system flags it for human review and automatically triggers follow-up observations. The system proved its value. In the first 3 months of operation, Sentinel AI identified 17 objects with anomalous characteristics that traditional analysis might have missed. Most turned out to be misclassifications or instrumental artifacts, but 2 were real discoveries. One main belt comet with unusually high carbon monoxide production rate, and a near-Earth asteroid with a rotation period so fast it should shed material from centrifugal force but somehow doesn't. The key point is we are entering an era of automated anomaly detection. No longer relying on humans to spot the weird, training machines to do it instead. And machines are good at this because they have no bias. They don't assume everything must look a certain way. They just compare data to models and flag the mismatches. If an object accelerates faster than expected, the algorithm notices. If composition is inconsistent, the algorithm notices. If the orbit is uncertain, the algorithm notices. Now applied to 3i Atlas. The object was discovered by traditional Chile survey maps, but many anomalous points were automatically flagged by the system. Unusual orbit noted right away because the orbit-fitting software detected hyperbolic. Composition anomaly flagged when the spectral pipeline compared data to standard comet templates and found large residuals. Sudden brightness spike detected because the optical monitoring system noticed deviation from the expected light curve. No need for humans sitting at telescopes saying this is really strange. The machines say it first. This is the future of small body science. Large-scale surveys like the Rubin Observatory coming online will detect millions of objects. Humans can't analyze them all. We need AI. We need systems to sift data, identify outliers, prioritize for follow-up. And as the system improves at recognizing patterns in anomalous phenomena, it will find more objects like 3i Atlas, even more, raising more questions. Is 3i Atlas special or just the first of a very many interstellar travelers detected now that we have tools to see them? 3 known interstellar objects: Oumuamua, Borisov. 3i Atlas found over 8 years. Detection rate about 1 object every 3 years. However, the rate depends on survey sensitivity. As telescopes get better, algorithms smarter, we find fainter, farther objects on less favorable orbits. The true population of interstellar visitors passing through the solar system at any time could be hundreds, thousands. We are just now developing the ability to see them. And if even a fraction of those visitors exhibit anomalies like 3i Atlas, if even 1% turn out to be artificial, operating in ways natural physics can't explain, then we live in a changed paradigm, shifting from a universe of rare, strange interstellar objects to a universe where they are common, a research system. And that universe raises the question of whether we are alone. The answer not through radio signals or megastructures, but through the behavior of small objects drifting through the neighborhood. Similar AI systems are the ears and eyes of the new era, tracking object 11-1200, building databases of characteristics, finding correlation, testing hypotheses, and when the next 3i Atlas appears, we are ready. There's a protocol in place. There are instruments pointed. Questions prepared. The universe is no longer passive observation. It is active interrogation, answering one anomalous object at a time. So where does this lead? What to pay attention to? What does it all mean? Part 15, Conclusion. Things to watch for future impacts. We are in November 2025 as we write these lines. December is approaching. 3i Atlas's closest approach to Earth on December 19th, and in the coming weeks, global telescopes will point to that patch of sky in the constellation Pisces, searching for the faint, fast-moving object and the possible debris cloud trailing it or not. Here's what they're looking for. First, expanded morphology. Does the object have a tail? Is there a large comet cloud expanding from perihelion? Any structure from massive material ejection? This is seen in optical and infrared images. Hubble JWST ground-based telescopes with adaptive optics systems taking photos. If the debris cloud is there, we see it, showing diffuse light, perhaps jet spurts fragments. Morphology tells if outgassing is uniform or localized, if the object is intact or fragmenting. Second, photometric measurements. Does brightness change as expected for a comet ejecting billions of tons of material? Look for specific signs, brightness correlating with sun distance, color changes, indicating dust or gas, emission variability, suggesting rotation or active regions. If mass loss, photometric data shows it. If not, a flat light curve displays characteristics not matching standard comet models. Third, spectroscopy. What molecules are present in the comet cloud? C. Expected volatiles. Water, carbon dioxide, carbon monoxide, cyanide or not. Any unexpected chemicals, industrial compounds, synthetic molecules. Ratios fitting natural outgassing or showing tighter control. Spectroscopy is the most powerful diagnostic tool there is. It tells not just what, but how much is reasonable considering other observations. Fourth, astrometry. Where exactly is the object position predicted based on gravity model plus inferred non-gravitational acceleration or not? If acceleration continues, Orbit deviates in a consistent way, strengthening the hypothesis that something is really happening. If position matches current predictions, perhaps the earlier deviation was chance or acceleration, only occurred at perihelion and is now stopped. Either way, astrometric data limits possibilities. Fifth, radio observations. Any radio wavelength emissions. Natural comets do not produce strong radio signals, but plasma or magnetic interactions might. An artificial object might produce radio noise from electronics power systems. Far-fetched possibility, but worth checking. ALMA. Very large array and other radio facilities listening. If there's anything worth hearing, it will be heard. Sixth, polarization. Any changes in polarization signature. Does negative polarization persist or evolve as the object moves away from the sun? Polarization is sensitive to particle size and composition. Changes could indicate new material exposure. Coma grain evolution. So those are the observations to be made. What happens or doesn't in the next month? And depending on what is seen, one of three scenarios falls. Scenario A. Debris cloud appears. Very large, bright, corresponding to 5 billion tons of ejected material. Acceleration fully explained by outgassing. 3I Atlas becomes the most extreme observed interstellar comet. Standard for future research, a reminder the universe is stranger than thought but governed by natural processes. Cautious outcome. What most scientists expect, meaning valuable learning on comet diversity, no need to rewrite textbooks. Papers published, models updated in a few years. 3I Atlases, just a footnote in planetary science history. An interesting footnote but not breakthrough. Scenario B. No debris cloud. Acceleration is real but without clear mass loss. Observations show activity, yes, but not nearly enough. Or wrong mass, wrong exhaust velocity, or something fundamentally different about this object. Outcome not comfortable. Forces consideration of incomplete physics or the object using an unknown mechanism. Possibly strange, natural, artificial, but not a normal comet. Opens door to speculation, debate, controversy. Some scientists argue for new foundational physics. Others hunt for data errors. A small but growing number increasingly suggest considering the artificial hypothesis seriously, not certainty, but a research-worthy possibility. Scenario C. Partial debris explains incompletely. Perhaps see some mass loss, but not enough. Perhaps photometric measurements show brightening but inconsistent. Perhaps spectroscopic measurements detect unusual molecules not fitting standard models. Outcome ambiguous. Unsatisfying because it resolves nothing. Just raises more questions, but most likely because reality and nature rarely gives clear answers. If it goes this way, the debate continues. More observations needed, more papers written. 3. Atlas remains a mystery at least for a while longer. Whichever scenario falls, the implications are significant. For interstellar object science, the space between stars is not empty. Objects drift through objects with compositions and behaviors reflecting origins. Some pristine remnants of planet formation processes. Debris from other collisions ejecting material, a very few something else. Understanding this population describes a field of astronomy. Each new interstellar visitor a gift. A sample from another star system sent for free. Just observe carefully to uncover the secrets. For planetary defense systems, objects with sudden acceleration are concerning. Current tracking systems assume known orbits predict future orbits with high accuracy. But if non-gravitational forces are significant, if objects change orbits in unforeseeable ways, prediction is harder. Not meaning the sky is falling, meaning need better models, better monitoring, better contingency plans. Need to account for uncertainty, need humility about what we don't know. For SETI, the search for extraterrestrial intelligence objects like 3I Atlas open new research avenues. Perhaps techno-signatures we seek are not broadcast programs or megastructures. Perhaps subtle anomalies in small object motion. Perhaps the strange point in interstellar visitor structure.